Hey there guys, how's it going? Mike coming back at you here with another video on Foundations of Math 2. In the previous video, we talked about approximating and or estimating. We talked about why we want to do that. Very important in several key instances in the real world, especially estimating costs and budgeting money. And we saw how we get or how we use graphs like bar graphs and pie charts or pie graphs to use that information that's given to us in those forms to then answer questions about approximating or estimating things like cost. In this video, we are going to talk about solving word problems. Word problems are not the most fun things in the world. Some people shudder in fear at the thought of having to solve word problems. They can be very tricky. They can be confusing at times. But in this video, I want to talk about a general method that we can use to solve word problems. And it's a general method because there's really no one particular concrete way that you solve all word problems using this one concrete method, but it's just a general set of guidance steps to help you solve word problems. So as I said, there is a method. It's actually a 4-step method that you can use to make solving word problems just easier overall. And it's called Polya's 4-step problem solving method. And the steps are as follows. You're given your word problem. First thing you want to do is understand the problem that you are being asked. Isolate key pieces of info. Write those key pieces of info down separately. Maybe give those things names if it is required or if you want to do so within the question. But first up is really isolate and write down the key pieces of info that you're going to need to solve it. Typically, all numbers that you see in the word problem will be used in some way, shape, or form. I say typically because there are instances where some extra information is thrown in there that's really not necessary. But for the most part, you'll be using most, if not all, of the numbers that are given to you within the problem. Step 2, you're going to come up with a plan as to how you're going to solve this problem. Sometimes you may need to draw a picture. Maybe you need to try certain combinations of things, and maybe trying this thing doesn't work, and then a couple more tries don't work, but then the next thing that you try does work. Maybe you have to make a list of something. There's various things that you can do. First up, you're going to carry out the plan that you think you want to go forward with. So this is where you actually do the work. You crunch all the numbers. If this doesn't seem to help you, or you think you're going off, then go back to step 2 and try to come up with a new plan. Around step 4, when you have an answer, make sure your answer makes sense within the context of the question, and then check to make sure that the answer is indeed correct. Make sure that it makes any equations true. And making sure that your answer is reasonable is a very simple yet powerful thing that you can do when it comes to solving word problems. Just as a quick example, you may be asked to find a distance or a length of something. And if you come up with an answer that's negative, then that should be your red flag of, oh, wait a second, this doesn't make sense. Distances, lengths, these are always positive values. I came up with a negative answer for it. Something has to be off here. So let's use this 4-step problem now to solve a couple word problems here. So my friends and I are setting up a rectangular area in my backyard for the Bills tailgate. I am from the city of Buffalo, so that's why you will be seeing me refer to the Buffalo Bills quite a bit. We are using the entire width of my backyard, which is 110 feet for the sake of this problem, and we have 500 feet of fencing to enclose this rectangular area. What length will use the rest of the fencing and enclose this largest possible area? So, first thing we're going to do, isolate key pieces of info given to us within the problem here. The problem says we're using the entire width of my backyard, 110 feet. We have in total 500 feet of fencing to use to enclose the entire area. We're looking for the length, and we need to use up the rest of this fencing. So we do need to use all 500 feet. We don't have the option to use less than that. We have to use all 500 feet. And we want to enclose the largest area as well. So just underlining here, we're just isolating some of the key pieces of info that we have. I'm also going to underline the fact that this is a rectangular area, because when it comes to rectangles, we know that the opposite sides have to have the same length. And that's going to come in handy when we go about solving this problem. So that was step one. I just isolated and underlined. You could also write it out separately, but isolate the key pieces of info that you're going to need to solve the problem. So step two, devise some kind of plan. I chose to draw out a sketch or a picture of some kind. So what I've drawn here is the portion of my backyard that's going to be used for this Bills tailgate. We were given that the width is 110 feet, so we have those two sides labeled 110. We have to use the 500 feet of fencing up on this whole thing. So this side plus this side plus this side plus this side, those all have to add up to 500. Well, we just mentioned that we highlighted the fact that this was a rectangular area, and we said that opposite sides of the rectangle are going to be the same, because that's just what it is by definition to be a rectangle. So we don't know what these two side lengths are, but whatever they are, they have to be the same thing. So let's give some name to each of these side lengths. Let's just call this X. So if that's X, we know that that has to be X. All right, so as we just said, we know two of the four sides. The problem told us what they are. It's a width of 110 feet of my backyard, and we're using the entire width, two sides, 110 feet each. And we know that the other two sides had to be the same length. So if I have 500 feet in total, and I subtract 110 and 110, then that is going to give me 280 feet of fencing left. So between these two sides, I have to use 280 feet of fencing. But since these two side lengths are the same, we have to get the same number. So what I'm going to do is I'm going to take that 280 and I am going to cut it in half. And when I do that, I get a length of 430 feet. Now, the question just asked what length we'll use the rest of the fencing. It didn't ask us to find the actual enclosed largest area. The question just asked us to find the length. So we can stop right here and say that our final answer is a length of 140 feet. But note the 4 steps that we actually did here. Step 1, we isolated key information within the given problem, as evidenced by what we underlined here. Step 2, we drew a picture, we labeled some things on that picture, and then step 3, we carried out that plan. We used the properties of a rectangle as well as our known sides and some basic math to come up with our answer. And now step 4, looking at our answer, does this seem to make sense? Is 140 a reasonable answer? And does it satisfy the condition that we need? Well, if I substitute 140 here and 140 here, well, 140 plus 110 plus 140 plus 110 is indeed 500 feet. So we are using the 500 feet of fencing. Yes, it certainly is a reasonable answer. We have a length that is positive, so that brings it into the realm of the answer being plausible. Next one here, a little bit different. We're going to use a different plan to come up with the answer here. So suppose you're in charge of buying gifts for 10 people for work, say for Christmas time or whatever. The gifts are going to be either phone cases, which are $16 each, or mugs, which are going to be $11 each. Your boss gives you $133 to spend on the gifts for these 10 people. How many of each should you buy so that you don't exceed the budget that you're given and you give as little money back to your boss as possible? Because your boss is a cheapskate and you want to make him spend as much as he can without you having to pay anything. So let's underline some key pieces of info that are being used in this problem here. We know that in total, there are gifts for 10 people. So the question is asking us how many of each should we buy. We know that whatever number of phone cases and whatever number of mugs we buy, those numbers have to add up to 10. We're given the cost per phone case, $16 per phone case, and we're given the cost of each mug, $11 per mug. And we know our total budget that we can spend maximum. We have to spend maximum $133. We want to get as close to it without going over it. It's kind of like The Price is Right. And then the question is, how many of each should we buy so that we don't exceed the budget and we give as little money back as possible? So there's the key pieces of information that we're going to need here. So drawing a picture doesn't necessarily work. I'm going to just try various combinations of phone cases and mugs and see what these costs are and just see which one will get me closest to $133 without going over. So I start off, okay, what if I just bought all mugs and I bought no phone cases? Well, each mug was $11. So $11 per mug times 10 mugs, that gives us $110. Again, note that it was 10 mugs and no cases because in total we're buying for 10 people. So there's only 10 gifts here. Then I said, okay, let me take one mug off and then add on one case. So what's it going to be for 9 mugs and 1 phone case? All right, 9 mugs at $11 per mug. That's going to give me $99. And then 1 phone case at $16 per phone case. That's going to give me just $16 there. Add those up, that gets me $115. Okay, let's take off another mug, and then let's add on another phone case in its place. So they're going 8 mugs and 2 phone cases. 8 mugs at $11 a mug. It's going to be $88 for the mugs. And 2 phone cases at $16 per phone case is going to be $32 for the phone cases. Add those up, it gets me $120. And I kept going on like this. I tried more combinations. 7 mugs and 3 phone cases, 6 mugs and 4 cases, 5 mugs and 5 cases, and we see the total cost here. Well, we see at some point, namely at 5 mugs and 5 cases, we have exceeded $133. Now, you could check and go 4 mugs and 6 cases, 3 mugs and 7 cases, 2 mugs and 8 cases. You could continue on like that, and you would find that all of those total costs would be more than $133. So all those possibilities are out. So looking at these costs here, what is the one cost here that is closest to $133 without going over? That is the $130, and we get that by purchasing 6 mugs and 4 phone cases. So we want to purchase 6 mugs and 4 phone cases, and that will spend as much of the boss's money as possible without going over the budget for that. In this case, the carrying out of the plan, the crunching the numbers, was a little bit different. There were some smaller calculations, but we had to do them a few times over until we found that right one that gave us what we were really looking for. And checking our answer, does this answer of 6 mugs and 4 cases make sense? Yes, it does, because in total, we're buying 10 gifts. And we were told in the problem that we're only buying for 10 people. And the numbers show that this is the largest amount of money you can spend without going over $133. So that is indeed our final answer. So these were just a couple sample problems that show how we can use Polya's 4-step problem-solving method to solve word problems. Again, this is just a general guide, a general set of steps that you can follow to solve word problems. Unfortunately, it's not a concrete method that you can use for every single problem that you see in terms of do this particular thing, and then do this particular thing, and then do this thing, and then you arrive at your answer. But it is a general guideline, and that general guideline does help at least a little bit. If you have any questions or comments, be sure to reach out to me. Send me an email. Throw up the bat signal. Send me a text. Whatever you have to do. Otherwise, until the next video, take it easy, folks.